we have PD, which is probability for D is 60, right? 60 per 150. Okay, FE, female student which has the black hair, we have 40 per 150. So please don't get confused with this one, right? Yes, this is the next question, but from the similar table, because I want to show you the difference. Okay, for the probability for D and E, okay, sorry, probability for the intersections of D and E. Okay, we can see here, what is the intersection between D and E, which is the male student has black hair and female student that has black hair. Okay, is there anything that intersect to each other? No. All right. Okay, I cannot see it. So the answer is, it is mutually exclusive. Mutually exclusive. Okay, what about the P, the probability for the union? Okay, again, we can look at the formula here. AB, so you have to add up all the value here. So I mean to say this is mutually exclusive to be 0, right? This value should be 0. Okay, so you add up all the value here, so you get 60 plus 40, 100 per 150. So that's how you get probability of the union of male student and female student. Okay, so also we can also cross check, right? Because the total for black hair male and female students are 100 here, so which is the same with the answer, should be 100. 60 plus 40, 100 per 150. Okay, next up is how to calculate probability for the unions if event N, A, B are mutually exclusive or of each other. Okay, just now as previously we have demonstrated on the previous example. So here, okay, look at the previous example. Because this one is 0, right? So we tend to ignore the later part, so we only have PA plus PB. Okay, so that's how it works. Okay, next up we have to calculate probability for the complements. Okay, let's move forward to calculating probability for the complements. Okay, as the formula suggests, before we come to the formula, okay, let me briefly kind of explain to you, okay, about the complement. Okay, let's say we are aware that this is complement, whereby for the set of events, if let's say this is A for event A, and complement was defined by this one, meaning to say that the outcomes of this does not intersect with the events of A. So this applies for this one. We say that for any event A, the probability of A to intersect AC equals to, of course, 0, right? And then next up is, since either A or AC must occur, thus, by following the third law, the probability of A union of AC must equal to 1, right? So having said that, the probability of A union to complement of A equal to probability of A plus probability of A complement, which equals to 1. So this is rearranged to come up with this, which is the probability of complement A equals to 1 minus probability of A. Okay, all right. So this is truly related from this one chapter to one chapter. Okay, moving on to the next question, which is from the similar table. Okay, looking at the table again. All right, so, but the thing is, the question is, calculate PF, which is the probability of F, which is the student is male. All right, but please pardon me for intersection, because actually this is not to calculate probability for intersection. It should be for complement, right? So okay, but whilst I was writing this, whilst I am writing this, so maybe you can just take a while, guys, or maybe you can just calculate first. Okay, this is complement, which is how to calculate probability for complement. Okay, have you got the answer? All right, so let's go. Let's find it together. Okay, how to calculate PF. Okay, this is PF. Okay, PF equals to, like in this case, should be PA. So how many? The question, and looking by referring to the similar table previously, so the probability for F, which is student is male, equals to 60 plus 25, right? So it equals to 85 per 150, as mentioned in the calculation here. Okay, let's proceed to the P complement to F. So from the graph, from the formula here, we can see that the complement, in order to calculate the complement of the A, it should be equals to like 1. After we have answered, we have found the, and we have calculated the PF, so it's time to find and to calculate the PFC. So from the formula here, the PFC, which is in this formula, it should be A, but we can change it to PF. Okay, so in this case, the formula is PFC, P, right, FC equals to 1. Sorry, pardon me for the bad handwriting. Okay, PF. Okay, something like this. So you get the calculation for PF already, which is 85 per 150. So 1 minus 8 per 150. So you're gonna get 65, right? Is it correct? 65 per 150. Okay, let's check. Okay, 65, 40 plus 25, so we have 65 per 150. Okay, let's move on to the calculating probability for the intersections. Okay, previously we found the probability for A and B, meaning to say the intersection of A and B directly from the table, right? Okay, like previously, for example, the table, for example, the exercise before, we can simply get the value from the table, which is 60 per 150. Sorry, but actually it's not that simple. Okay, for such cases, the rule for calculating P, probability for A intersect B, depends on the idea of independent and dependent ideas. So basically, this is the general rule or the general formula for probability for A given by B, which equals to probability of A intersect B per probability B if PB is not 0. Okay, so let's move on to the next slide, which is on the conditional and unconditionality.